everyone. It is Hugo Bowne-Anderson here for Out of Bounds. I am so excited to be here for a fireside chat with Jacopo Tagliabue. What's up, Jacopo?
Oh, good, man. How you doing?
I'm very well. I'm very well. Very excited to be here today to talk about reasonable scale LLMs, reasonable scale AI, all the wonderful work you've done previously on reasonable scale machine learning, opening up the world of machine learning to non-FANG companies, among other things. I would love to welcome everyone who's joining the live stream on YouTube. If you can introduce yourself in the chat, that would be super cool. Let us know who you are and where you're calling in, where you're watching from, and what you do, what your interest is, and those types of things. That would be super cool. I also just want to say a bit about Out of Bounds. Out of Bounds builds productivity tools and a platform for data scientists, machine learning engineers, AI engineers. They can help you build machine learning, data science, AI applications, including LLMs, and work on all types of tools for data scientists as well, such as the open source Metaflow, which I will link to the GitHub repository in the YouTube chat. And if you like this type of thing, check it out and give it a star and share it with friends. This is a project that's used across many verticals across hundreds of organizations these days. Jacopo's done a lot of work with Metaflow, but it's really to help you with full stack machine learning and all your infrastructural concerns. It was open source at Netflix in 2019, garnered so much adoption that our colleagues and friends built Out of Bounds, which was initially around Metaflow, but is a lot larger now. So definitely check it out. I don't want to say much more about anything except Jacopo and what we're here to talk about. So I just want to read Jacopo's bio to him because I love it so much, and he can correct anything from his own written bio. Jacopo is educated in several acronyms across the globe: UN, ISR, SFI, and MIT. Co-founder and CTO at Tuzo, an AI startup that was acquired by Covio, doing a lot of sophisticated information retrieval recommendation systems that have been used across quote unquote like mom and pop stores, but at reasonable scale, not FANG companies. And Jacopo led Covio's AI and MLOps roadmap from scale up to IPO and built out Covio Labs, an applied R&D practice that collaborated with Stanford, Netflix, Farfetch, NVIDIA, a lot of open source, a lot of open science. And now you're building Bauplan, which we'll get to. I wonder if there's anything I've left out there, but besides being an eminently handsome man and also being the first person to be invited to an Out of Bounds fireside chat for the second time. Is there anything else you'd like to add to your biography?
I'm like Roger Federer. So I'm like, when I win this 7 times, it's gonna be like Federer at Wimbledon, I guess. So it's like now I'm 2 out of 7, which is amazing. So thanks so much for having me back. Of course, thanks to all of our friends at Outer Bounds, listening in. And thanks to everybody that stopped by and for this chat today. No, I think it was a perfect introduction. I'm always excited to talk about recommender system, information retrieval, AI, and especially the interface between data and machine learning, which is where I build most of my recent career. And fun fact, if I may, so we mentioned Metaflow before. Our probably most used open science contribution, which is called Fashion Clip, which is a clip model only for fashion. And it's been the most downloaded clip model after the OpenAI one for months in Hugging Face. It's been downloaded tens of millions of times. Has been actually trained with Metaflow. So if you go into the original paper that we publish in one of the Nature journals, you're gonna find the Metaflow procedure to actually train Fashion Clip.
Fantastic. And I'm going to link to Fashion Clip on Hugging Face. And I don't have time to find the Nature paper at the moment, but people can Google that.
Yeah. You can go from Hugging Face to the repo, and then there's all the links to all the several, let's say, artifacts that comes with the project, including the papers and a bunch of other stuff.
Very cool. Well, let's jump in, man. Maybe we can set the scene by having an introduction to what even is reasonable scale machine learning, and then we can start thinking about reasonable scale LLMs and reasonable scale AI and all these types of things.
Of course. So I think so. If you rewind the clock a bit with me, Hugo. So 2020, 2021, the Cambrian explosion of the MLOps ecosystem, everybody starting to get crazy for ML and AI. Those was the glory days before, LLM, but there was still a lot of ML and AI producing tons of value, tons of business value across many use cases. What was different at that time before, compared to 2017 or, 2015 when we, all of us started doing data science and ML? And the answer is, well, there's a lot of tooling and a lot of best practices that started consolidating at that point, which allowed an important switch. The switch between, hey, this thing is cool, but it's so hard and only 10 companies on the planet have the engineering skills and infrastructure to make this work, to get value out of it, to, hey, this is cool. And sort of everybody else, quote unquote, but most people can actually now get value of the same type of models that, the people in Netflix did. And there was a momentum shift. And the reasonable scale ML was a catchy phrase that was meant to capture this important moment in time. When normal company with, hundreds of people, not tens of thousands, dozens of engineers, not, hundreds, and we, hundreds of millions of data sets or rows of data set, not petabytes, could actually put models in production and generate tons of value. That was necessarily not true before. And so that was kind of the, how this all started. And so we identified a few principles together in that sense to make sure that people are like, hey, if you want to start doing this, don't be scared. Don't go on the Uber blog post. They're cool, but they're not going to tell you anything that, that is actually relevant for you. Start pragmatical. Start with how things actually can get built, and then you can build on top of it. And that's, how this entire series started. I saw you're sharing, our original blog post now. So
yeah, so this is episode 2 of the blog post, as
yeah.
you know, link to it in the YouTube chat. I'm wondering if this will help frame the conversation at all, if you could talk us through this figure.
Of course. So, I mean, there's like, we have this, Gartner-like quadrant, which is,
I love me a 2x2.
Yeah. And so so the argument was, hey, there's like, four type of companies that want to use ML, right? So there's like the top right, which are the people that invented this practice, like the Netflix, the Facebook, the Google of this world. And they definitely don't need, our help or, particular tooling at that point. There are people on the bottom left, which are called the small animals, which are like, very, very small, digital players. Let's say you have a small, Shopify shop, but nothing bad with it. It may become giant one day, but today you're probably mostly not using machine learning. It's like getting people to actually go on your website. And then there are the two other quadrants, which has been the one neglected for years, by tooling and by best practices, which is the late adopters. So people that may be gigantic company, the financial institution of this world, large B2B software, but kind of like a previous generation, which obviously they have the scale to make ML significant, but they don't have the, let's say, sophistication or the talent, or they're just a bit late in adopting all of these, new tools. And on the other side, there's like people like me, the early adopters, which are the people that are actually pretty advanced, but they don't have, the working company that has too small to have an entire ML platform team supporting them. And so they need tool to move fast and, hopefully break not too many things. This is the typical fashion clip stuff, right? So
Yep.
people that really know what they're doing, but they want to leverage existing tools so that they can actually focus on one thing, which in this case was like fine tuning and evaluate a new model, and not the entire infrastructure around it. And so if you take these four, these four animals, you find that, two of them, which are, by the way, where the mass majority of people work at, are actually the type of companies that will benefit from reasonable scale.
So cool, man. That sets the scene very nicely. And I love that you mentioned there are kind of several pillars, and you already hinted at some of them, as opposed, like in terms of, you don't want to build everything internally for reasonable scale ML. You don't have the infrastructure team to, build Michelangelo, like Uber's platform, right? Or a fully fledged experimentation platform. So I'm wondering, before we get into reasonable scale LLMs and AI, if you could just talk me through kind of what the pillars of reasonable scale machine learning are and what people need to think about?
Yes, so I think in our original version of this, there were like three important points. The number one, which we will see is even more important today, is the realization that when you think about machine learning at reasonable scale, there are two components, right? The data that you feed to the models and the models. And one of these two things is way more important than the other. Perhaps counterintuitively, the most important part is data. Okay, so data sourcing, data wrangling, data quality, data engineering, it was actually going to squeeze the most out of your ROI. Models get commoditized very quickly. Even before LLMs, you think about Hugging Face, like most people will end up using most of the same base model to do sort of everything. So by definition, if everybody's using the same model, the differentiating factor cannot be the model, right? And so if you want to be competitive in the ML world at reasonable scale, a lot of attention needs to be put on data. So data over models, I would say principle number one. Principle number two, you don't really have that much data and it's okay. So I don't know, some people say big data is that, some people say, AL to the small data, whatever you want to call it. But there's the realization that in most cases, when you go outside of FANG company, you actually have very high quality data sometimes, but not in large quantity. At the end of the day, it's very common to have hundreds of millions of rows, not hundreds of billions. And that reflects in a good way, in a sense that simplifies a lot of the choices that you need to make to actually get ROI of all this. So the second principle is you probably have small data, and that's totally okay. That's exactly what you need if the quality is good enough. The third one is the importance of tooling. Okay, so we already kind of mentioned it with the buy versus, build versus buy kind of dilemma, but like a huge part of ML data science project is speed of iteration. The reason is because unlike software, when it's very easy to sort of like, understand even when you're doing things right or wrong, ML and data sciences are a bit more fuzzy. Even the criteria for success are kind of not exactly known as sometimes before you start. And so the faster you iterate, the better it is, which means if you don't have enough engineering resources, don't spend time building an ML platform. Buy or reuse open source ML components and spend time doing the ROI thing, whatever that is in your case, because otherwise you're never going to get to any result. If you spend all your engineering time building a platform, nobody's going to actually create, the value that you want to do. So I would say principle number three is like, iterate as fast as you can, however you can, which in many cases means buy software instead of building yourself.
Love it. Data over models. Small data is usually okay. And iterate quickly, which usually involves buying some sort of infrastructural tools. Awesome, man. I already have a sense of where this is going with respect to AI. There are so many ideas at play here. And to think about, we do live in a culture where, you might remember Chris Anderson's blog post nearly 2 decades ago or whatever it was of like the end of scientific theory in the era of big data. We don't need theory anymore. But if we remember stuff like, one of my favorite examples is actually Kepler, who developed his 3 laws of planetary motion. He did that using Tycho Brahe's astronomical data on like 1,800 data points or something like that like to get the laws of planetary motion, my friend. So if Kepler could do that, I mean, we're not all Kepler, but and we're not all Brahe either. But now that and where my mind also goes is, small amounts of data can be fine. Now with generative AI, the ability to synthetically generate data, like we need to be careful there, but that opens up all types of possibilities for reasonable scale AI. But I am getting ahead of myself. So these considerations, and I'm actually going to break it into 4. So data over models, small data is okay, then iteration is key, then tooling is an absolute concern, and buy some stuff. Of these 4, how do they change or stay the same with the introduction of generative AI? Or what's changing now with generative AI?
So I think there's so a lot of the things about Gen AI are sort of the same of the things that we were doing before. Maybe the weights of the features are changing, but many of the important components of a good and healthy ML like practice I think they're still there in many cases. If you're training your own model, like if you do, Llama fine-tuning and all of that, we can go into that. I think they're very new, exciting opportunity for people that decide to skip their entire phase and just basically buy, like an available API, like an OpenAI, Anthropic, or whatever you want to use, which will actually make things like, slightly different from the good old world they used to know. But generally speaking, I think the importance of data is reinforced by GenAI in two sense. Like since the pre-trained models contain so much freaking knowledge about the world, and everybody's using the same 4 or 5 model to fine-tune their data. Again, the marginal difference, what's going to make you competitive cannot be the base model because it's the same for everybody, is your own data. So I think good small set of curated data is even more important now than before, especially given the capabilities of GenAI models to somehow suck it in and kind of like, change their behavior accordingly. And of course, a lot of people complain about hallucination. For those of you who don't know, like, sometimes GenAI model spits out things that are like plausible, but not exactly true. And one way to ground this behavior is through RAG or, information retrieval system that actually feed them real information. So data is definitely, even more important than before, I would definitely say. So that's part number one. The small data, totally fine. This model has been trained on basically the entire internet, so they don't need much to be nudged towards what you're gonna do. In fact, I'm happy to quote my friend Piero Molino, the inventor of Ludwig at Uber and one of the founder of a company called Predibase. There's extensive evidence that if you fine-tune open source model on your very specific data set, you're gonna actually outperform large commercial model. And again, shouldn't be much of a surprise. Large commercial models are very good at Wikipedia type of things, but they may not know anything about your particular business case. And so even smaller model with good data will actually do that. So these I will say again, even more important. I would say it's not the same. It's even more important than before. And for iteration, I think that iteration in build versus buy is where I think some of these things, some of the analogy breaks down a bit. I don't know what you've seen in the last 6 months, Ugo, but like on my side, I saw a swap between ML and GenAI in the following sense. Iterating in ML, even the first iteration, is usually pretty painful. Doesn't matter how good you are, how good of a platform you have. Like building even a POC of a recommender system, it's kind of a drag. And then there's the last 20% that you do to put this in production. With GenAI, I saw the opposite. Being a demo that you can send on Twitter and getting people excited takes 5 minutes. But then bringing them to production is like 90%. Like now there's a gigantic, gap between that demo and production. I don't know if you saw something like that in your recent adventures.
It's so funny you mentioned that right now. Let me just see if I can find this in my notebook. And this was a drawing that was inspired by a conversation with Ville Toulos, who built Metaflow and is co-founder of Out of Bounds. Let me just, no, I've got the wrong notebook. Okay. I can't do this right now. But essentially, I drew 2 figures. One, x-axis is time, y-axis is excitement. And traditional ML and software, you build a prototype and it's not that exciting, and then you add some tests and then you like more and more exciting. Whereas the other figure was very exciting in the first 5 minutes of generative AI apps. And it's like, hallucinations. And it's like, how do I monitor? I don't even have the training data. So how to think about data drift? I need to get this in real production software. How do I do that? And so on. So I couldn't agree more with respect to what I've seen. This actually dovetails very nicely into my next question. I wanted your thoughts on, so we've definitely seen that the principles of reasonable scale ML not only hold in generative AI, but perhaps are even more important now. I am interested, having noted that, what challenges we face in reasonable scale generative AI. What new challenges have emerged? And I've hinted at some of them. The other one I think that you've kind of already spoken to is the lack of an objective function. And that's why the field of evals needs evaluating the performance of your models and your systems is so important. But yeah, what new challenges do we have now?
I think so. The main challenge at least in my experience talking with customers, talking with people in the field, talking to my friends, is always the same for reasonable scale companies is how can I know if this is a good use case for Gen AI? Question number one. So like, of all the things that I want to do, I know that, shareholders want me to do Gen AI. I know that I open Harvard Business Review and everybody's doing Gen AI, whatever. But like, how do I know if the 5 problems that I have in front of me are a good case for Gen AI? Because there's nothing worse than trying to solve a non-Gen AI problem with Gen AI. It's going to be incredibly expensive and incredibly frustrating. So that's problem number one. Problem number two is like, even assuming that these use cases is actually able to be solved by Gen AI, it's the best possible way to solve it. How do I measure the ROI on this? Like, I don't want to build this entire cathedral in the desert just to find out that this thing is useless, right? So how do I get very quickly to the point which I can make a judgment call of say, okay, makes sense to invest more or less. And if you think about it, these are exactly the same question that we data AI leaders were asking ourselves, in the previous iteration of all of this. Like when ML was starting to get to a good, points in the market, people were like, well, why do I use this? And B, how do I even know, if I'm using it correctly? I don't know if I'm getting value out of this. So I think this is, maybe now there's more pressure, as in I see a lot of executives from companies that are traditional companies, not FANG companies. They need to show data and AI initiatives even more than before. But the fundamental questions, I think, remain the same. And the way to answer is exactly the same as before.
Yeah, that makes perfect sense. I suppose I want your thoughts on the types of things that are important and have always been important for data-powered software, whether that's like analytics or ML or AI or whatever we're going to call these things are, in my humble opinion, are being able to look at your data and like the types of things you pick up, and being able to evaluate and then having rapid iteration between those. And those things actually do become somewhat more challenging with generative AI, don't they?
Absolutely. I mean, absolutely. So look at your data. So problem number one, in many cases of Gen AI, you don't know where the freak the data was because there's no data. You provide, let's say you're using an API by a commercial vendor to solve your Gen AI problem. Totally reasonable. Maybe we're going to talk later when it's reasonable, but totally reasonable thing to do. You can feed some data into context, but you have no idea how this thing has been trained. So, your ability to sort of like think like the models is sort of like diminished in that sense. And evaluating is like a million times harder because most of the models we used to deploy in production, ML, like quick professor like recap. So most of use cases in ML are either classification or regression. So there's even a set of labels that you need to guess which one is correct, or there's a number that you need to be as close as possible. Okay, it's very easy to evaluate these two things. If the label is correct, otherwise it's wrong. If the number is close, it's good. If the number is far, it's not good. The nuances to this, we can get into this. But this, at a first approximation, there's a very easy judgment. Now, if I do a paraphrasis of my introduction that you said before, Hugo, how do you judge if this is a good paraphrasis or not? Like, if I leave out the fact that I study in X and Y, right, was still a good paraphrasis? If you leave out that I'm a co-founder now of another company, is this a good paraphrasis? Like, how does it count as a good paraphrasis? It's actually an unsolved problem. And so if you think this for all the Gen AI use cases, like how do you reply as a sales chatbot to a customer? It's much harder to figure out, even at a fair approximation, what's good and what's bad, which I think is both a fascinating problem and an enormous challenge to putting things in production and sleep soundly at night.
Great. So I'm a data scientist. I'm a machine learning engineer at a reasonable scale company. And I've put reasonable scale ML models into production. Now my company wants to start deploying generative AI in production. We need to identify a use case that's useful. What practical steps can I take and my company can take to leverage generative AI without like jumping into all massive resources, infrastructure, that type of stuff?
I think my usual suggestion is always like try to get some signals from the market before investing too much in a feature use case. We're talking here about, let's say, an existing organization try to deploy a new feature. We're not talking about a startup whose entire product is X. Okay, so we're talking. Okay, so yeah, so just so we're clear. And the way in which I would have done it before, let's say in the good old days of ML, is like put in production the stupidest possible model possible. Let's say we're doing a spam classifier. I know it's an old use case, but everybody knows it. Okay, I will put together some, biased, stupid, naive classification to do that. Let's have a 1% of my user look at it. Let's see how it goes, and then we can assess about how much impact are we having, how good it is, and then we can do BERT or whatever fancy stuff.
Mm-hmm.
What does it mean to do that in the Gen AI case? It's even easier. So that's, I think, the incredible thing about Gen AI is that some of these models are literally available on tap. Like you can literally call an API. You don't even have to import Hugging Face. You can just import request or whatever you want. And you can literally call an API that somebody else is maintaining for honestly a pretty decent price overall and tried out your feature. Okay. So in that case, what you need to identify, so you have the use cases, good for you. You don't need to really care much about the model itself because the model is provided through an API, like it's a service 100%. What you need to identify is like what context goes into this model to solve these use cases. So immediately your first question is, what is a good data to solve this problem? And we go back to your problem, like look at your data. In this case, not the data used to train the model, but look at the data that we as a company have and that we as a company can fit to this model. Because if we as humans looking and reading through this data cannot solve the problem, why do you think something else will be able to?
Yep.
Like, so I think the first thing will be crossing all these, checking all these boxes. And then if all of that goes well, just put it in production, 1% of your user, see how things are going, and then decide if you want to invest more. If you want to invest more, you probably want to do the equivalent of BERT before, as in now we cut out the API and we train our own llama or whatever. And now we go back to a much more expensive, much more, lengthier iteration, higher stakes, but hopefully fine-grained control and all of that. It's always a balance between how fast you get a response from the market and how do you scale a system once you get a positive response. I feel that in many cases, people, especially engineers, tend to invert the importance of these two things. So they want to build the hard things first without knowing if this is useful later. And I think this is a general mistake, but it's even more a mistake in a world when you can actually call models through an API.
1,000,000,000% agree. I am interested now in thinking a bit more about the build versus buy question. So in this, and actually, let me just say one thing. I love the idea of rolling it out to 1% of users first. Something I've seen, for example, for customer success, chatbots or conversational AI assistance software. I've also seen it work. Roll it out internally to your customer success team first, and they can give thumbs up, thumbs down. That's the other thing, of course, is allowing users to have a way to give rapid feedback. So even if it's thumbs up, thumbs down, or something like that, in order to get those things, so we can use that next. We've talked about APIs. We know people self-host open source models. Llama 3.2 recently was, as far as I'm concerned, a game changer. I love that they called it Llama 3.2 as well, because 3.2 after 3.1 suggests it's an incremental change, whereas I think this was like a pretty serious step function. Like they've got a 3B bloody language model and a 9B multimodal vision model. They're setting up infrastructure stuff. It's very exciting times. But I'm wondering, for me at a reasonable scale company as a machine learning engineer, what should I be buying? What should I be building? How should I think about that? Maybe my data, I'll have privacy and proprietary concerns. So sending them to APIs, maybe I don't want to do. So how do you just weigh up all these complex considerations in this space?
I mean, as usual, it always depends on the constraints of your own, company, team, and all of that. But there are some general guidelines that I think apply to everybody.
Please.
The first guideline, which is the one that we discussed, like, keep it simple the first time. So deploying models in production, it's hard even when it's a linear regression, which is something that we deeply understand. It's something you can literally expect with your own eye. You can make the calculation, on your Mac because, it's a summation. And it's hard. Like things still go wrong every single time people deploy a regression in production. Imagine a model that has been distilled from the entire, human readable content on the internet, whose inference mode is unbounded. Like it can literally say whatever the freak it wants. Okay, so
Mm.
imagine how hard it is. So the first thing is like, we need to cut the complexity every time you freaking can. Okay, so the less moving pieces, the most straightforward things to do is the first thing to start with. And then again, you evaluate your results and then you go back. So that applies to everybody. On the privacy concern, a lot of our customer as well in data, so let's say the adjacent, the necessary condition for models are very privacy sensitive. If you go to enterprises, a lot of them don't really want their data to be sent over the wire, over the public internet, to a third-party provider. So they want to self-host it or host it in a private link configuration with the provider in a single tenant scenario. So in those cases, you either find a provider that provides you with all this nice enterprise-ready feature, or depending on your budget and technology abilities, you can decide to build it yourself using open source. We mentioned Metaflow before, of course, is one of the most important ML platforms that are available and battle-tested in the system. What's the downside of that? The downside of that is with this model, even the smaller fine-tune you're going to be, the smaller inference you want to be, you're still probably going to be using GPUs, which are scarce and relatively expensive all in all. So let's say, even the most minimal things you can do is still not that minimal. So my suggestion will always be, try to not do this if you can. Of course, if it's the only thing you can, given your constraint, that's the only thing you can do. But even the smallest possible end-to-end fine-tuning pipeline with LLM is still, slightly expensive and sort of convoluted, even with the best possible tools. Again, a million things can go wrong. So if you can delay that moment, try to delay it as much as possible. If you cannot, get the best tool on the planet to do it. So at least you take some of the friction out. But it's more of an art than a science. I think the other thing that a lot of people, non very technical people, sort of underestimate is that just because ChatGPT works so well, it doesn't mean that your own model, fine-tuning your model, will work as well. It's not the same thing. The model is much smaller. You haven't spent nearly enough human time to look at it. So if you start small, at least you can adjust your expectation internally, with your business stakeholders, instead of spending a lot of money to basically maybe be disappointed a month later.
That makes sense. And emotion I've seen, and we've all seen, I think, is people starting by operationalizing their models using a closed vendor API, and then getting enough data from those interactions in order to start thinking about fine-tuning self-hosted open weight models around that. Of course, there's a skill set issue as well, and the cost of such an issue. I mean, to employ someone who's adept at fine-tuning self-hosted models isn't an insignificant cost, right? To be frank. So
yeah, absolutely. Probably dominates. I mean, up to a certain point, that cost is going to dominate your GPU cost or your tooling cost. That's for sure.
Without a doubt. And so, I mean, the provocation is, so our mutual friends, Hamel, Hussein, and Dan Becker taught a course on fine-tuning. And one of the takeaways from the course was, please don't fine-tune unless you've tried everything else first, right? Well, I suppose my question for you is, we've danced around this a bit, but we've kind of identified that people are using similar models. Of course, some perform better than others, but a trend we've seen recently is that there seems to be some sort of model convergence. And you could imagine, in some time, I'm not going to put an estimate on it in public. I've done it in private. But I'm making my bets on prediction markets. No, I'm kidding. But I'm just doing that for the upcoming. No, I'm joking.
For the upcoming what? Is there
Yeah,
anything
exactly.
important? Is there anything important coming?
Exactly. The upcoming gladiatorial combat in the Colosseum in your home country, in the real Rome. Sorry, I lost my train of thought completely. Yeah, you could imagine a world in which kind of most models end up being the same, right? And so I think we have identified, even not in that world, like own companies' data will become increasingly important because we're all using similar models. But I'm wondering, when proprietary data becomes more of a competitive edge, are we needing to fine tune with that, or can we do like some pretty sophisticated in-context learning, or few shot prompting, or for lack of a better term, prompt engineering. I don't use the term prompt engineering, but well, I do, but I don't like it because there's nothing engineering about it. And that's not to, I love it. It's just not engineering, right? It's more incantations or like, making elixirs in a big pot. But I suppose my question is, when we use proprietary data, how can we expect to use it, and what type of skill sets do we need for that? What does a reasonable scale company need to employ to be able to do that?
So I think I reached the my age where I can be grumpy and somehow counter trend. So I actually can say that I actually really do not like prompt engineering. It makes me feel like I'm kind of like I'm trying to second guess this gigantic black box, like as you said, like an incantation is kind of like Harry Potter type of things. It takes all the like it takes a lot of the good thing about software out of the software. So it's cool in the sense of like, oh, it's a new way to interact with stuff. So when I'm actually, if you need to show something as a magic trick, is amazing. But when you think about building a reliable system at scale, is actually the opposite of what I actually like. And again, I reached the age when I can be old and grumpy about all novel stuff, and hopefully I get a pass for that. But that said, looking at your data is very important, which means the ability to slice and dice, query your data, visualize your data, and kind of like become one with your data. I always find is the most important thing in general for model training. One tiny fact about my life, my previous life, just to give people a sense. So the context is the following: like we were building a recommender system for people shopping in, let's say, incognito mode. So people are shopping, but you have no information about who they are, where they're from. The only thing you know is what they're doing right now. So you know that they're looking at this product and this product and so on. So it's all in real time, but you have absolutely no other context aside from it's called the session for the user, right? And so the challenge is how can you build a recommender system that just using in real time information to do what is called session level personalization. And to do this, the first thing we did, what was the first thing we did? Was not training any model. Was like building a pipeline from our, in that case, Snowflake instance, and a web app for internal use only that will fetch real session from user, will enrich them with metadata, so pictures of products and descriptions, and will basically simulate, like unroll sessions in front of our eyes. And we as humans, we will try to guess what the user wanted to buy in that session. So we basically played the role of the model with our own cognitive abilities as human to even try to distill if there wasn't a signal in our data to try and solve the model in the first place. Like, are we even gonna be able to solve this model? Is there even anything here that can be used? You have no freaking idea how many anonymized user sessions of people shopping for shoes I've seen in my life. Okay, but after doing that for thousands of sessions, we build enough confidence in our data that this could be built. And there were like trends that the model could pick up in as good, or in that case, better than any human could have done. And so we actually went on and built the model. In our case, we already knew how to build a recommender system. We had all the MLOps in place. So all of that effort was sort of already paid off. But the first thing we did was basically sit down for a week just with our data to do that. In that case, we use a warehouse because our data was fairly simple to put in tabular form. There are other ways to do that. But that's definitely the first thing that I would do. It's like I will sit down with my data and will slice and dice it in the way the data is supposed to be used by the model. And I will try to behave like the model. Like be one with the model that I'm trying to build and try, hey, is this thing can even be done? Of course, this doesn't apply to everything. Like, if you're trying to predict the stock market, your human intuition doesn't have any role into this, right? But there's a million things, especially in Gen AI, where you're trying to literally mimic something that human already do, like a chat, like a customer support conversation. If you cannot do it as a human with your data, again, how can this thing work in the first place?
Makes sense. I didn't want to talk about this, but it's so important, and you've been leading the witness in some ways in terms of being able to sit down and look at your data in even a sensible way. You need to have your data logged. You need to have your ETL set up correctly. You need to, have your pipelines set up. So perhaps you could tell us a bit about the importance of we talked about the main tenets of reasonable scale machine learning. We didn't talk about logging in relation to transformation. So maybe you could just tell us a bit about that.
Yeah, I mean, that's of course, a topic that I deeply love. Is kind of like was one of the motivation behind us starting like a data transformation company after a first ML company. So again, we believe data is like, the most important thing, or one of the most important thing. But data doesn't come out of the tap like all fresh and clean that you can just take it and put it into a model. Data needs to be clean, transformed, aggregated, and as we said, like, you just need to, visualize your data or slice your data or filter your data. And there's different way to do that. We always recommended, like even before it was cool, this approach of like, log first, think about it later. What does it mean? Is like, you have your own app or whatever use case you're trying to solve, and you're going to receive some data about user usage, some data about, in the case of recommender before, where people clicks on a page, and things like that. Make sure to store all of that. Make sure to store all of that, which may sound like an incredibly naive thing, but you'll be surprised by how many times I saw company that want to solve a problem and they never even logged one of the important data before that. If you log everything about your universe, whatever your universe is, you're not gonna find yourself in the predicament of like, oh, I want to do Gen AI and I never logged anything. So my first point to everybody who wants to build data-driven products or analytics or whatever is log as most as you can. Why? Because logging things is actually surprisingly easy today in the cloud. It's a million tools, front-end and back-end allows you to do that. And second, because storage is dirty cheap. So the things that are gonna, balloon your cost in your cloud is not, I can guarantee you, your S3 or object storage cost. Before that becomes a significant line item, you will have to store a quantity of data that doesn't make any sense. You won't be a reasonable scale anymore, and it means your company is so successful that you have an epi problem to solve. But most of us that stores terabytes of data, even tens of terabytes, will pay like a very, very, very fraction of our entire engineering budget in S3, but we can sleep soundly at night. We can sleep soundly at night because we will know that 6 months from now, when the business come to us and say, I want to build, this happened to us, I want to build a recommender system and takes into account the geographical position of users, which we didn't do before. And it's like, you know what? We actually logged, the approximate GPS coordinate based on IP for our entire history of the company. So we just can go back now and use it. We never used that column before. Now we have it. So instead of waiting 6 months to get enough data, we were ready to do it. How did we do it? As you said, by building data pipelines. So the data is there. So challenge number one, data is logged, done. Challenge number two, how do we get from the data that is logged into the model? And that's where the ETL comes from. Like, how do we make good pipelines and good transformation?
Awesome. So I want to jump to the other end of the iterative process of, I suppose, the software development lifecycle, for lack of a better term. As we know, and as we've spoken to already, moving from research to production can be tricky, even more so with these generative AI apps. So I'm wondering what just some of the common challenges that smaller organizations have faced and are currently facing when operationalizing. That's harder to say than Jacopo Tagliabue. So yeah, what are some of the common challenges that smaller orgs, reasonable scale orgs face when operationalizing generative AI, and how can they overcome them while maintaining reasonable scale deployment?
In my experience talking to customers, always kind of like, two main phases. The first phase is, hey, this thing works as a notebook or the equivalent of that on somebody in my team laptop. How do you go from that to an automated process? Okay, which involves refactoring the notebook into something that, computer can actually run properly, containerized on a schedule and blah, blah, blah. So all of that part, the first refactoring is always like kind of like a big hurdle to do that. So from I run this clicking on play to this thing runs every night or whatever there is, and I can sort of sleep at night. So that's problem number one. And this can be solved by I wouldn't say get out of notebook in the first place, even if that's what I believe personally, because I don't like to develop in notebook. But that's me. I'm old and grumpy. I'm entitled to have, counter-type opinion. But at least to have tools that once you have a notebook things working, allows data scientists to somehow self-serve and build the entire pipeline. What you want to avoid at all cost is having two orgs One would just do notebook, and one basically who takes the notebook and have to kind of like, decipher what is in the notebook and then rebuild it everything in the pipeline. There's a million tools that help you be a good software engineers, even if you're not being trained like one. In the ML side, we mentioned before, Metaflow. In the pipeline side, if you want, Bauplan and others. So there's solution now for this problem. So this is problem number one. Problem number two, once you figure this out, there's how do I make sure that the things, so when I sleep at night, now I can sleep at night because the system works, but how can I be sure that I can sleep soundly? How can I make sure that this model is not going to ruin my reputation as a company? It's not going to damage me and so on. This used not to be a problem with most machine learning models because what we said before, they were like very limited abilities to basically give answers. Generative AI models can say terrible things. And the word, like if you Google 3 seconds, you're gonna find spectacular cases of failure. One of my favorite one, which is completely harmless in the great scheme of things, but of course you don't want that to happen. I think it was like Chevrolet, whatever, I don't remember, like very famous car manufacturer. There's a sales bot. And then if you ask which is the best car, they're gonna say, hey, you should buy a Tesla. It's like, wait, what? So, maybe it's a good suggestion in the great scheme of things. Maybe it's an honest suggestion, but I'm sure that people at Chevrolet were not super happy about it. Air Canada deployed a chatbot that completely invented a refund policy, and they've been sued and condemned to pay, of course. Because of that. Again, all these things, like there's one every week to do that. And I think this is a second challenge this is peculiar to Gen AI, which is, okay, now the pipeline, the engineering part is done, but how can I make sure that, this model doesn't go out of control? And I think while the first one is a relatively solved or kind of like getting solved problem, thanks to all these startups doing incredible cool tools, the second one on the real-time evaluation, it's obviously more of an open quest. And I don't think we as a field have already cracked the nut yet.
So yeah, you've really hit the nail on the head with both of those. But the second one kind of speaks to my next question. When we're thinking about deployment on the other side of the coin, or even you look at a slightly different angle, we're really talking about monitoring as well, or it's a necessary part, right? So I wonder, as organizations accelerate development and deployment, how can they ensure they have robust monitoring and evaluation systems in place? What are the key components, for lack of a better word, of a successful AI monitoring strategy for reasonable scale organizations?
The narrower use cases, the least likely is the model to say things that are completely, outrageous, right? So the more open-ended the field, the more you can make up stuff that you don't want the model to do. So the first thing is like, if you start small as usual, start with something that has a limited, somewhat like, surface of attack. So the amount of stupid things that can come out of the model is kind of like smaller. Second, do your freaking test before. Before even putting in front of 1% of the model, try it internally, try it yourself. This cannot be stressed enough. This was true even before. It's like the same thing as I said, act like your model, which means try to do the job that your model is doing. Also implies once you have the model, look at your model prediction one by one for weeks until you're sure that you can somehow build a model sorry for the pun of word, a mental model of what your endpoint is doing. It's super important for you to check mistakes manually for a while before deploying to get a good sense of where the model is good and when the model is not. And maybe design a UI that steer user away from the zone, the danger zone in the model, and actually nudge the user to ask something that the model can actually do. But again, be one with your model. You should know all the failure use cases, or most of the failure use cases, before you put it in production.
Beautiful, man. I'm both inspired by and scared by the concept of being one with your model, particularly when they can be so large and daunting. Something we've been talking around is the fact that with a lot of these models, well, all of them essentially, you don't have the training data. So like in the previous paradigm of reasonable scale ML, most of the time we're training our own models so we can monitor data drift and model drift and have a sense of what's happening there. Earlier when we were chatting, you made a good point, which I've thought about a bit and we haven't talked enough about publicly, is that this paradigm of inference APIs essentially it seems new in the generative AI age, but it actually isn't, right? If you go back to even Hugging Face half a decade ago, even longer, being able to set up inference endpoints with pre-trained APIs, BERT, these types of things, right? All of these things were possible. So these concerns kind of reared their ugly heads then. But what new challenges emerge when we have these black box APIs as well, with respect to thinking about your data versus training data and so on?
I mean, I think that there's few of them. Some of them are probably super basic, and is like, it seems to me, but I'm not, don't quote me on it, but it seems to be that sometimes it's even hard to understand if what's behind those API is stable or stable enough that you can count on it. You know what I mean? Like, if people retrain the model without telling you, are you going to expect the same prompt to get different answer the day after? Which seems to be the case. Seems that in many cases, people get somehow dumbfounded by vendors kind of like, changing or switching things up behind the scene, which is contribute to the general non-deterministic feeling that doesn't make me like, this entire prompt revolution super much. As an engineer, again, not as a user necessary. So that's problem number one. The problem number two with data is that, perhaps controversial opinion, but the reason why large language model works so well is because we're basically testing on the training set all the freaking time. Because if the model is large enough to have read the entire internet, the chances of what you're asking to be actually out of distribution is almost negligible. So the reason why the model looks like it's really, really good in what is answering is because the model has already seen this or an interpolated version of this in the manifold.
Yeah.
That is actually very close. In fact, if you try hard enough, and there's a million of examples in symbolic reasoning, there was a Apple paper very recently on math reasoning, the model is actually not that good. It just so happens that most of the use cases that are, producing business value or consumer value actually can be reduced to something that the model has already seen somewhere. And so it's very easy for him to somehow interpolate the answer. What is the problem? The problem is that since you cannot fathom, I mean, you don't have the data set in the first place with OpenAI. But even if you had, it's probably such humongous thing that is very hard to wrap your head around it. But it's very hard for you to anticipate the out of distribution. What I said before, like, what are the failure mode of your models? If you have the data set or the data set is manageable, it's much easier for you to build your mental model of, okay, this is the data that I have, this is the data that I don't have, I expect the model to suck at this. But now I have absolutely no idea what this model has seen before. So it's hard for me to even guess what this model will suck at. And so I think this is a massive problem when you need to guard against these, very bad rare events. So, you know what I mean? Like there are use cases in which one very bad thing destroy the entire use case. Think about self-driving cars. It doesn't matter if you're right 99.9% of the time. If you kill somebody in the rest of the cases, that's not good enough. So I think a word of caution for closed model especially is, since you have no idea to know what went into the training, do not deploy them yet for critical, mission critical use cases, because you have absolutely no idea what that long tail event looks like.
That makes sense. I wonder, in terms of wrapping up, there are several directions we can go in. I do want to think about the future of reasonable scale LLMs. But before that, I am excited to hear about what you're up to at the moment. We have been talking about data pipelines and data engineering. We've been on the cusp of that conversation. So I'm just wondering if forward thinking, future music, as we could say, looking ahead, how do you see tools like Bauplan playing a role in simplifying the data side of things? So data engineering, streamlining the deployment of generative AI for companies at reasonable scale.
So I think one of the problems that we've seen over and over again in ML, but now even more with Gen AI, is the fact that the people that build and iterate on the model may not be necessarily the people that then once can are need to put this in production, right? So a lot of we call the team topology that we've seen in the data world are kind of like this big fracture between people that are able to do some part of the job, but not the entire, kind of like, full end-to-end stack. And they're like, skill reason, historical reason for why data people are sort of a more heterogeneous set of practitioners than normal software developers, which on the other hand, struggle more with data statistical concept. And so one of the raison d'être from Bauplan is the idea that this does not need to be the case, especially the reasonable scale. Like, there may be tools that are simple enough to work, in our case, on the lakehouse. So on architecture that are built completely in object storage in your own cloud, so super enterprise friendly, privacy friendly, where people that speaks a bit of SQL and a bit of Python, that know their data, should be able to basically run production level code in the cloud. And so Bauplan ergonomics has been designed to look like a CLI tool. You interact with Bauplan, you interact with Docker, for example, or Git that everybody knows. And the idea, you can just throw code at it and it will basically schedule and run for you on the lakehouse, and being preoccupied of all the things that needs to happen, right? Containerize things, talk iceberg, move data around with Arrow, producing views, producing tables, and all of that. So kind of reducing the friction from, I have an idea, I have some code that works, to how does these things now run on a schedule, every day or whatever, to produce values? Because I still think that that's the biggest bottleneck. Like, if models gets on tap, the more models get commoditized, the more the hurdles to production are gonna shift left to all the engineering that needs to happen for production, instead of being, at the very far right with all the training and all the usual things that we used to know from the previous life.
Awesome. And far out, man, I love that you're working on more human-centric approaches to data engineering and turning it into software as well. That's super cool. Anyone who hasn't checked out Bauplan, please do, and check out Jacopo and Chiro's and everyone else's great work there. Funnily enough, as you know, Jacopo, I'm in Berlin at the moment, which isn't too far from Dessau, which I went to once and stayed in the former Bauhaus studios there. So it's fan. I mean, Paul Clay's studio is there, Kandinsky's studio is there, and they've got the old studios where the students used to stay. So you can sleep, you can rent. So I went there with work, actually, went on an offsite there.
Awesome.
We rented out 20 rooms in the old studios. Beautiful, and it's actually very Zen vibes. Like, they create the rooms so that you're inspired to create. Fantastic stuff.
You just give me like a fantastic idea for our next offsite. I didn't know you could rent it
Exactly.
out. So that's a fantastic.
Exactly.
That's a fantastic idea.
Yeah. So to wrap up, then, I'd love to know generally. So at the moment, we've talked about a lot of people are pinging vendor APIs. As generative AI continues to evolve, what place do you see for smaller, more adaptable models in industries that are kind of dominated by large resource-intensive models? And how can smaller orgs carve out their space?
So I think like, say, two possible future. Future number A large model keeps on getting better at the same rate that they did in the last couple of years. It looks unlikely, consider the sort of like plateauing on the field in that sense, but it's a logical possibility, right? And so if that's the case, it means the large language model will be so good that the general one will be able to solve most of the specific use cases that small models now excel at. So in that case, the industry will probably shape up as a oligopoly with a few large models kind of like solving most of the use cases. Not dissimilar from the cloud model, when we have three basically vendors that are kind of like taking 99% of the share. Future B, which I think is a bit more likely as we speak now, is that large models are sort of there and they're great and they're still doing marginal improvement, and I'm sure they're going to still improve, but they're nowhere close to the price, performance, latency, privacy constraints that a lot of companies care about, for the reason that we mentioned before. And so what I'm expecting there is expecting the startups like Metaflow, and Otherbounds, Predibase, blah blah blah, startups in the tool chain of fine-tuning, serving this model to become easy enough for the general reasonable scale developer to use. And in that case, smaller model will dominate the enterprise use cases because of the constraint that we mentioned. So depending on which future we're going to live in the next 3 years, I think we're going to see either a renaissance or like a growing of the smaller model for the B2B cases, not the B2C. And then, or on the other side, like a huge oligopoly form by the few companies that can train large language models that are all encompassing at that point.
Great. Well, I know where I'm going to put my money in the prediction markets. I'll tell you that. So final question. We've had a kind of a wide-ranging conversation around what reasonable scale generative AI can look like. If you were to give one piece of advice to organizations trying to adopt reasonable scale AI, what would it be?
Start small and check. Start small and check. Check means check before you put in production, and check after you put in production that these things is actually going to create the value that you think you will. Because if the answer is no, there's no need to go deeper into that. Doesn't matter how many Harvard Business Review article you read this week.
Fantastic. Start small and check. And check, of course, involves the two things we've been talking about the whole time, which are looking at your data and look at your evaluation framework as well, and see what you're trying to get your software to achieve, and is it achieving that goal?
Yep.
Jacopo, I just want to thank you for your time and generosity, and also for being the most charming, grumpy man I think I've ever had the pleasure of speaking with. You may say grumpy things, but you're a wonderful smile.
I know sorry, like it's kind of funny because you started this saying that I'm very handsome, which of course I am. But I just realized now that as part of my view, I don't know if you see this actually, but there's a picture on my back of me. Do you see the picture? There's a picture.
I do see a picture, yeah.
Yeah, and that's that's tiny me. That's tiny me with the aviator glasses. I know how well you can see this, but that's tiny Jacopo with the aviator glasses. When I was not, I was already very handsome, of course, but I was not nearly as grumpy as now. So I'm happy that you could see the entire evolution from small Jacopo to grumpy Jacopo in one frame.
I mean, it's been a whirlwind of a trip. I also love how that Hornets flag kind of looked like a hat on you for half the but I'd also like to thank everyone who watched in real time. Thank you to the 50 or so people who joined, and everyone watching after. Thank you for joining. And join our Slack and get in touch with Metaflow and Out of Bounds. Thanks once again, Jacopo.
Thanks, Hugo. Thanks, everybody. If you want to reach me, I'm very easy to reach. Just send me a message on LinkedIn. I'd be super happy to chat about any of this topic, even more.
Fantastic. And scene. We're done, man.
Cool. How was it?
That was super cool. I mean,